Hi everyone, I'm going to introduce a new function from PyHydroGeophysX package. And the new function is a new features, like we can use Agentic AI Workflow in Qt-based user interface. It's much more user-friendly and it's much more stable. So I'm going to use 3 demos today. The first one is to use new workflow to process seismic refraction data, and the second one is process ERT data. And the last one is how can we use new function to simulate geophysical measurements with hydrological modeling. So let's go to our package. So if you download our package from GitHub, then this is our folders structure. You can go to the examples first. And then you can just double click the start web app. So you can see this. This is in Windows. If you use other system, it's similar. So then we can just go to this click here. Then you can have this Steam list websites, and this is a previous page. You can use the Agentic Workflow still in websites, but here we develop new professional workbench, and we can use Qt interface. It's much easier and more stable. So just click here, open in Qt, and you can just wait for a while. And those are all functions included in the Qt system now, and we will have more in the future. So this is our professional working bench, and this is our acquire chat where you can use agentic AI here. You can use OpenAI Cloud or other things, other models. And so first thing we need to do is just copy the API key here. For example, this is my API key. Then just use apply. Then you can see this is a ChatGPT 4.1 ready. So next step, you can just say something here in the chat box and to process. So let's go to first example, processing seismic refraction data. We can just easily type, help me process seismic refraction data. Then just send. Then you can see the agentic AI, they will tell you what is wrong. You can just approve. Then you can see then it guide us to the seismic windows. Then you can just describe, it will describe how you can use these windows. So this, you can see this is a seismic processor modules is ready. So first thing is tell us we need to provide our seismic data path. So then we can use our example data. So we can tell the data is at, this is where data located in my desktop. So then if you want to load, you just approve. So this is our data. You can change it to see the images and the wiggles. So it's very clear. You can see the first left time. Then the geometry is like the topography and the location, something like that. So we can also load, tell the agents like where the geometry file is at. Still, it's a local path. Yeah, still approve, just approve to, then it will load the path. Then we can just, if you want to pick up nice shots, we can just approve. You can see it's automatically pick all the time, all the first left time. But you can see some are not very good. You can just repick by yourself. It's also very easy. You can use control and pick. It's much easier. Then after you finish it, you can just continue. Yes, you can see all the setup is also changed automatically. Then you can just pick up not very good again by yourself. After you're done, just tap continue again. Yeah, you can see it's very efficient. You just remove some not very good one, and for other things looks good. You just continue. I mean, just pick up quickly here just for demo. So if you want to pick more accurately, you can later by yourself. It's done. After it's done, you can see this is travel time. This is inverted seismic velocity. This is topography. And you can also see the inverted quality here. So this is example for the seismic data. And now next we can show you how to process ERT data with our workflow. So still similar, like you just see, okay, help me process ERT data. Yeah, blue. Then it just tell you. So let's go to this is ERT windows. Then here you can also use your file path type here and tell it where it can load automatically by itself. Or you can just use here interface here. Much easier. For example, here we just want to add file. And then we want to find an example data ERT, and we have some E40 files. And we just load one. Okay, just saying I already loaded the data. Let me invert the loaded data. Then you just approve. That's good enough. Yeah, you can also ask is it done or status or continue. So there are lots of options. You can just use your natural language to control whole progress. Okay, now as you can see it's done. The immersion complete. And so this is our inverted result. Still, you can see the inversion quality here. And you can, of course, you can also change the different parameters. You can change here, or you can just use your natural language to change. For example, change your lambda. For example, like we change inversion lambda to maybe 1 and do inversion again. Yeah, it's done. You can see the lambda equals to 1 is less smooth. So this is you can just change the inversion quality. It's also become different. So if we have multiple EIT data, for example, we just load more, and so now we have 3 data, and we can see now we can see after we load 3 data, you can see now we have 3 uploaded EIT files, and I want to do 10 labs EIT inversion in low memory setup. Low memory setup, we just save the computer memory if you have limited memory. Yeah, you can see the time lapse too, low memory too. Yeah, it looks great to me. Now we just prove wrong. And now it's start doing the time lapse inversion. Okay, now you can see the time lapse inversion results. So this is a time step. So this is time 0. This is another time. And this is another time. So you can see it's very convenient to do a time-lapse inversion too. And we also have a different function for time-lapse inversion. You can see you can also use a window time-lapse inversion too, like low memory. You can see there's an explanation here. So you can use both user interface or use natural language to control our system. So the last example I want to show you here is to see how can we couple the geophysical data with hydrological models, especially how can we use hydrological models to simulate geophysical measurements. So still we can just tab. I want to simulate both ERT and SRT, which is seismic data measurement from the hydrological modeling output. Yeah, so it's go to modulars, I guess to see modulars of from the hydrological model to geophysical measurement modulars. And this can tell you how to use it. So define the models how to do next. So here we use a default example here now. And then we can first say we need to define 2D profiles. Let's say I want to pick up profile from the map. So this is a map. This is a map for our hydrologic model. Then we can just pick 2 points here, and then we continue. This is setup. This is the default parameter. So you can change parameter and rock physics models if you want. Now I here just use default to continue. You can also say information from the bottom. It's the coding information. And now you can see the results. This is ERT resistivity model from the hydrologic model, and this is simulated appearance resistivity. You can see here. So, and you can also change it to the seismic. So this is SRT, this is seismic velocity, and this is seismic travel time. So this is super helpful if you want to couple the hydrological model and the geophysical measurement. And also we have other functions here. For example, we can also use geophysical data to get hydrological property. For example, use seismic data to get subsurface structure, and also use ERT data to get subsurface water content. And for the geophysical data, we can also process EM data, gravity, magnetic data, and also we have a 3D matrix builders. Like we can build 3D matrix, like for the borehole measurements or for the 3D geophysical survey. So we can actually like different formats for the future inversion and also for the modeling. So let's say we have several engines to generate different 3D matrices. So which is very useful to couple the hydrological models and the geophysical measurements, because most of the hydrological models are in 3D. So this is all the introduction to our new features today. Let me know if you have any questions. Thank you so much.